All right, greetings. Today I want to talk about L'Hopital's rule, sometimes called L'Hospital's rule. L'Hopital, I'm not sure on the pronunciation. And this is just going to be a short video. There's a link online to lecture notes and sample problems that I found. But basically it applies whenever a limit is going to be of the form 0 over 0 or infinity over infinity. And what it says is that if you're taking a limit and you have a fraction f of x over g of x, then that limit's going to be the same as if you're doing a fraction with the derivatives. Right? So you take the derivative of the top, you divide by the derivative of the bottom. Note, let me just kind of point this out, you don't use the quotient rule here. So this isn't about quotient rule, it's not about the derivative of the fraction, it's just sort of saying that we take the derivative of top and bottom. So I thought I'd just kind of quickly go through. Let's choose a bold color. Let's do orange. So if we have a limit, so kind of the typical work I might do is I might check this, and I might plug in infinity. If I plug in infinity, I'm going to get infinity on the top and infinity on the bottom. And so that's going to be a clue to me that I can use L'Hopital's rule. So by L'Hopital's rule, I'll write that as LH. I have that this integral, or this limit, is going to be the same limit as x goes to infinity of, let's see, that's going to be 6x squared plus 4 all over negative 18x squared. And now I can plug in again, so let's plug in and see what happens. Well, if I plug in infinity, I still get an infinite number on top and an infinite number on the bottom. And so I'm going to write again that I'm going to get infinity over infinity. So I can use L'Hopital's rule one more time. So I can use L'Hopital's one more time. I'm going to get that this is equal to the limit as x goes to infinity of 12x over negative 36x. And now I'm in a position where I can cancel. Right now I can do a quick algebra step, cancel those terms, put this in lowest terms, and I'm going to see the answer is negative 1/3. Right? So that gives us an example of how L'Hopital's rule can help us by simplifying a problem. Let's just do a few more. So I'm going to do the limit as x goes to 0 of sine of 4x over x. And so if I just plug in, I'm going to get sine of 0 over 0, which is 0 over 0. And so L'Hopital's rule is going to say that this limit is going to be equal to the limit of the derivative, which is going to be 4 cosine of 4x over 1. And now when I plug in, I'm going to get 4 cosine of 0, which is 4. So the limit of this function as x goes to 0 is going to be equal to 4. I've got the next one. We've got a fraction as t goes to 0 from the right of log of t over 1 over t. First, let's check. If I plug in 0, I get log of 0 over 1 over 0. That's going to be infinity over infinity. So that is one of my L'Hopital's rule cases. So I can use L'Hopital's rule. So L'Hopital's rule is going to say that this is equal to the limit as t goes to 0 from the right of the derivative of the top, which is 1 over t, divided by the derivative of the bottom, which is negative 1 over t squared. And now when I simplify that, I'm going to have to do a little bit of algebra, but when I do that little bit of algebra, what's going to be left is the limit as t goes to 0 from the right, just of t. So that t is going to remain after I cancel, and I guess there's a minus sign there. And that I can evaluate, that's going to be 0. So we've just checked that that limit is 0. And now we get to our very last one, and this is what comes up sometimes, is sometimes we have a limit, and when we try to evaluate it, we get an indeterminate form. In this case, we're going to get 0 times minus infinity. And this is sort of makes us want to use L'Hopital's rule, but this is not currently a fraction. And so here we have to do a little bit of rearranging. So we'd like to use L'Hopital's rule. And what we can do is we can say, well, this is really the same. I'm just going to rewrite it. T times the natural log of t is no different than the natural log of t divided by 1 over t. Right? So just pause for a second and think about whether or not those are the same. And then we can ask, well, now, if we try L'Hopital's rule, well, it's just this problem up here. And so we've already done that problem. We know that that answer is 0. And so that's what we're going to do. So typically, this will come up. It came up the other day in class, I think, where we did an example where we did the limit as x goes to minus infinity of x e to the x. And I think what we did was we wrote that as the limit as x goes to minus infinity of e to the x over 1 over x. Actually, hang on. I think we could try that. I don't think that would be as effective, though. I think the way we wrote it was actually x over e to the minus x. And in that case, we could check. We could see what L'Hopital's rule would say. This would be negative infinity over, let's see, e to the plus infinity. And so that's infinity over infinity. And then we could just go through. We could use L'Hopital's rule, would say that this limit is equal to the limit of the derivative of the top, which is 1, the derivative of the bottom, which is negative e to the minus x. And then when we carry this out now, when we plug in, we're going to get 1 over e to the minus x. Well, if we plug in minus infinity in for x, and we do negative x, that's going to be e to the infinity. So that's going to be a really huge number. And so this is going to be 1 over a huge number. And so really this limit is going to be 0. So that's a real whirlwind tour of L'Hopital's rule, but it's kind of the details that we'll need. If you have any questions, of course, leave comments, send me an email, and I'll see you soon. Bye.